Hmm. Hi guys, just let me check if I'm live now. Can't see myself live. Just give me a moment. Yeah. So, is it live? It's not live yet. Let me check again. Okay, maybe I'm live now. Yes, I am live now. So, okay, hi guys, how are you all? Let me know in the live chat. आप सब कैसे हो? I am hoping that all of you are happy and healthy. Okay. So we are, as you guys know, I am your chemistry educator, Kirti Sharma, and I welcome you all to this session. And as you guys know already, that we are going to, ace your term 2 exams with Unacademy Plus, right? I hope you know this, correct? So let's begin. Let's see if somebody is here. Yeah, it's clean now, I believe. Yeah, better. Okay. So, a very formal introduction as usual. Welcome to the class, my dear learners. And as I just said, my name is Kirti Sharma, your chemistry educator. I have done my graduation from University of Delhi, and I have more than 5 years of teaching experience teaching students like you. And let me know if you have any doubt. I will try my best to help you. Okay. And okay, let's get started. Cool. So let's begin. What are we going to study today? Okay. So we are going to do our states of matter, right? This will be our lecture number 3. So we will do states of matter. Okay, that's what we are going to start with, states of matter. And share this session with your friends. And if you guys are planning to take the plus subscription, then you can use my YT code, and that is Kirti S Live. It is my YT code, that is Kirti S Live. You can use this code, okay, and you will get additional 10% discount on plus subscription. And as you guys know that the batch has already been launched. The name of the batch is Mavericks, and it will be launched on I believe it is 17th of January. So another batch is getting launched, so you guys can join very soon, right? I would say join as soon as possible. Okay, so yeah, let's get started. But before we go ahead, I want you to follow Unacademy Champions on Telegram so that you won't miss any of the class. Okay, the link is given to you in the description box. All right, and so that you will get all the notifications, all the updates of the class. So simply you can join the Telegram channel. Okay. Now, of course, since we are on YouTube, so subscribe us on YouTube right now, and we are targeting a thousand subscribers in the beginning, and very small target this is, I believe, and you guys can help us to achieve this target, and I believe it will be done really very soon. Okay. And if anybody enters the class, let me know in the live chat. Okay, so in the previous session we discussed what are various gas laws. So we saw that like when you want to express what is special about your gas, or what are the characteristics of your gas, so what you do is you tell me like what is the pressure of your gas, what is the number of moles of your gas, and what is the volume of the gas, what is the temperature at which your gas is present. So these are the variables, right? As you change these physical conditions, like your pressure, volume, temperature, number of moles, the gas shows different behavior. Okay, so in order to study this behavior, like how these things vary, we study gas laws. Okay, so gas laws are relationships between these variables. Okay, so in the first place, we discussed what is Boyle's law. So we know that what is Boyle's law? It is the relationship between yeah, it is the relationship between what? Pressure and volume, correct? Boyle's law depicts the relationship between pressure and volume, we saw. And we know already that pressure and volume are inversely related. This is just a quick recap which I'm giving you. If you have not attended the previous session, then go and watch it. We have done everything like regarding the gas laws. This is just a quick recap for you guys. Okay, this is just a quick recap for you guys. So yeah, what is Boyle's law? It is the relationship between pressure and volume, and we know that these two are inversely related. That is, if one increases, then the other one will decrease. Okay, as you can see here, that Boyle's law states the relation between volume and pressure at constant temperature and mass. That is, you have taken like a fixed mass of gas, you can say fixed number of moles of gas you have. So Robert Boyle conducted an experiment on gases to study the deviation of its behavior in changed physical conditions. So it states that under a constant temperature, when the pressure on a gas increases, its volume decreases. Or in other words, you can say that according to Boyle's law, volume of the gas is inversely proportional to the pressure when you keep the temperature constant. So that is another way of saying that. Then we derived the expression in which we said that P is inversely proportional to V, right? Or you can say P is proportional to 1 by V. So then we applied a constant here, and it turns out to be P is equal to K1 into 1 by V, or simply K1 upon V. So you know that the product of pressure and volume has to be constant. So what you did, your equation, this comes out, that is P1 V1 is equal to P2 V2. Okay, now the product of pressure and volume will remain a constant value. Okay, if you change any of the one quantity, then the another one will adjust itself in order to keep the product of pressure and volume as constant. Then we did the graph of pressure and volume, right? So as you know that this is the graph between pressure and 1 by volume. If we draw the graph between pressure and volume, it comes out to be like, what is the shape of the curve in that case? It comes out to be a hyperbola, right? So it will be a hyperbola, as you can see here, right? It will be a hyperbola. So this is the graph between pressure and volume. Okay, remember this at some constant temperature T. And I told you in the in surface chemistry chapter as well, that we are doing for class 12. I told you in yesterday's session as well that isotherm is a curve. I told you that isotherm is a curve which is drawn at constant temperature, which is drawn at constant temperature. Okay, that's what you call as an isotherm. जब भी आप किसी कर्व को ड्रॉ करते हो or at some constant temperature, that is the temperature does not change, it is called as an isotherm. Okay, whenever you draw a graph at constant pressure, okay, let's write this here. Okay, whenever you draw a curve at constant temperature, let's write this way: curve at constant temperature, at constant temperature, you call it as what? You say that this is your isotherm. It is your isotherm, right? If you draw a curve at constant pressure, if you take the pressure as constant, in that case it is known as isobaric. Then what is the name of the graph? It is your isobaric. And if you take the volume constant at constant volume, at constant volume, it comes out to be what? It is called as isotherm, isobaric, isochoric. It is known as isochoric. Okay, so that's the key to remember. Remember these three, that a curve at constant temperature is called as an isotherm, a curve at constant pressure is known as isobaric. Okay, and isobaric curve, and a curve at constant volume, it is known as isochoric. So I believe there is no doubt in this. iso का मतलब होता है already same. iso का मतलब होता है same. You can remember this way. The therm word is always related to temperature, right? Temperature or heat, right? Like you always study thermodynamics, you deal with heat and temperature. You have your thermometer, right, which tells you the body temperature. So again, therm word is related to heat and temperature. Okay, so iso means same. Baric, you can remember it as like the unit of pressure is bar, right? So in isobaric, if a curve is given to you as isobaric, it means that the curve is drawn at constant pressure throughout. Okay, you did not vary pressure, the pressure was constant throughout, you did not change it. Okay, Kavita Kushwaha, hi beta, good afternoon, how are you? Okay, and isochoric is for at constant volume. Okay, just simply let me know beta if you have any doubts in this. Okay, have you watched yesterday's session, Kavita? Next we did Charles' law, and Charles' law is the relationship between volume and temperature at constant pressure. So we know that I am also good beta. When it comes to Charles' law, you define the relationship between volume and temperature of the gas, and we know as the temperature increases, volume of the gas also increases. So whenever you deal with volume and temperature only, you keep the pressure as constant. Okay, what do? You say that we have taken pressure as constant, that is pressure does not change. Okay, if pressure initially was 2 atm, then like it will be 2 atm throughout. Okay, so I believe it is okay. And when we deal with pressure and temperature, because we know that as temperature increases, pressure also increases. So in this case, what do? When we deal with pressure and temperature, we keep the volume constant. Okay, volume and number of moles constant. Then we derive these relationship, that is your Boyles law, Charles law. So you should know what are the things that you're keeping as constant and in which law. Okay, so Charles uncle found out the effect of temperature on the volume of a gaseous substance at constant pressure, you can see here. And we know that volume and temperature are directly related. Okay, So you can say from here, say let's deal here, volume and temperature are directly related. So when you remove the proportionality sign, you will add a constant, you will apply a constant. So this will be V is equal to KT, and then you got to know that the ratio of volume and temperature will come out to be equal to a constant value. Okay, so you can say from here that V1 by T1 will be equal to V2 by T2, and this will be equal to V3 by T3 up to Vn by Tn. Okay, and this ratio will always come out to be equal to some constant K. Okay, a constant value, somebody asked me in the previous lecture, constant is something which does not change. Okay, if the ratio of volume by temperature, if the value of V by T comes out to be say 2, then it will be always 2, whether you vary V1 by T1, say it is 6 by 3 or 4 by 2 or 10 by 5 or 100 by 20. So whatever is it, it will, sorry, so it will be 100 by 50. So it will be always coming out to be 2 if your constant value is 2. Is that okay, Kavita? Okay, let me know beta in the live chat if you have any doubt, and share the session with your friends as well. Okay, now let's go ahead. The Gay-Lussac's law is the relationship between pressure and temperature, you can see, and from here you will get that P1 by T1 is equal to P2 by T2. Okay, again here the ratio of pressure and temperature comes out to be constant. So again this value, same thing that we did in the previous law. Okay, you can see as these two are, pressure and temperature are directly related, so the graph will be a straight line passing through the origin. Okay, we have already done this in the previous session, okay, in the previous lecture. That is why, like, it was just a very quick recap, okay, so that you guys won't get out of the track. Okay, now we have Avogadro's law. So Avogadro's uncle, like Avogadro uncle told us that at constant temperature and pressure, you can see here, at constant temperature and pressure, he said no matter what gas do you have, he said the volume of all gases constitutes an equal number of molecules. Okay, and he also said that at constant what was I saying? Hi Pragya, how are you beta? He also said that at STP, standard temperature pressure conditions, what will happen? He said that all gases contain 22.4 liters of volume. Occupy, not contain. I would say that they occupy. Let's change it. All gases occupy. Let's write it. All gases occupy 22.4 liters of volume. So this is something very important which is regarding to Avogadro's law. Okay, then we did this question, if you guys remember, in the yesterday's session we already did this question. Let's move on to the next one. You can see here you have given here pressure P1 and its corresponding volume was V1. So you need to tell that at pressure P2 0.2 what will be the corresponding volume V2. So you can just simply use P1 V1 is equal to P2 V2. Okay, put the values and you will get the answer. This we did already. We did this question as well. Yeah, let me know this question. We did not do this question. What is the name of the graph that is drawn when the temperature is kept constant? Batao. Bacha Party, Kavita, Pragya, let me know. What is the name of the graph which is drawn when the temperature is kept constant? Let me know, Kavita. Tell me whether it is an isotherm, isochoric, or isobar and isobar, like both. Only isochoric या फिर isobar. Tell me. Just give me a moment. Yeah. So yeah, the graph which is drawn at constant temperature is known as what? It is known as an isotherm. What is it called? It is called an isotherm. Okay. I believe there is no doubt in this question. Let's move on to the next question. The next question says, at constant temperature, the question is saying that at constant temperature, the pressure of a gas is given as 1 atmospheric pressure and 5 liters. Like pressure is 1 atmospheric liter, 1 atmosphere, then the volume is 5 liters. Okay. When the atmospheric pressure is increased to 2 atm, then what is the volume of the gas? So let's see if we use Boyles law here. What do we use? We use Boyles law here. So we can say that according to Boyles law, we know already that P1 V1 come out to be equals to P2 V2, right? So let's take our pressure P1 was like 1 atmospheric pressure, then the volume was 5 liters. Okay, let's write here P1 as 1 atm, its corresponding V1 is 5 liters. Okay, very simple this is. When your pressure was doubled, then quite obvious you got it already, then your volume will be reduced to half, so that the product of this pressure and volume will remain a constant. Okay, so you can just do it in your mind as well, that when your pressure was 1 atm, then the volume was 5 liters. Now what will happen if the pressure is doubled? The volume will be reduced to half, so that the product of pressure and volume will remain constant. So 2 should be multiplied by 2.5 in order to get 5. It is as simple as that. But okay, let's calculate V2 from here. So it will be P1 V1 by P2. This will be, let's put on the values. So it will be P1 is 1 atm, V1 is 5 liters over P2. P2 is 2 atm. So it's again it comes out to be 5 by 2, that is your 2.5 liters, right? I believe there is no doubt in this question. Okay, very easy it was, guys. Let me know in case of any doubt. Okay, I'm expecting there is no doubt till now. Okay, so what can you say? That the volume when the pressure is 2 atm, the volume of the gas will be 2.5 liters. How much it will be? It will be 2.5 liters, right? No doubt till now, I'm guessing. Next question. What is the shape of the graph that is drawn between pressure and volume? I've told you in the today's session as well. What is the graph which is drawn between pressure and volume? It will be a straight line, it will be circular, it will be parabola, or it will be hyperbola. Let me know, Kavita, Pragya. What will be the shape when you draw the graph between pressure and volume? Here you have pressure, here you have volume. I told you already that the graph is something like this, right? And this is known as hyperbola. What is this? This is known as hyperbola. So the shape of the graph that is drawn between pressure and volume is hyperbola. Is that okay? I believe there is no doubt. Let's move on to the next question, which says there is a ball that will burst if the pressure exceeds 0.2 bars. Okay, like there is a ball. If the pressure exceeds 0.12 bars, it will burst. Okay, the pressure of the gas is 1 bar and the volume is 2.5 liters. When the pressure of the gas is 1 bar, the volume that particular gas occupies is 2.5 liters. So we need to tell what can be the maximum volume that the ball can be expanded. So basically we need to tell that at 1 bar pressure the volume is 2.5 liters. Then you tell me what will be the volume of the gas when the pressure is 0.12 bars, right? Because it cannot exceed 0.12 bars, right? So solve the question and let me know in the live chat what will be the answer. Quick guys. Solve it and let me know what will be the answer. I'm waiting first for you guys, alright? Okay, so let's see what we have. When the pressure, say P1, was equal to 1 bar, okay? Then at that point, your volume V1. At that point, your volume V1 was how much? It was 2.5 liters. Correct? Now, if I'm telling you that the pressure P2 cannot exceed 0.12 bars inside the ball, okay? So what will be the volume V2 at this point of time? Tell me. That's what we need to answer. Simply, this is the case of your Boyles law, right? Pressure volume relationship. So which law this is? We can say that according to Boyles law. According to Boyles law, I would say that P1 V1 is equal to P2 V2. P1 V1 is equal to P2 V2, right? So from here, let's simply put the values. We need to find volume V2. So it will be equal to P1 V1 by P2. If we put the values, P1 is 1 bar, V1 is 2.5 liters and your P2 is 0.12 bars, okay? So when you solve this, let me know in the live chat guys, what will be the value of V2. So basically it is just simply 2.5 over 0.12. Very simple calculation. Your volume will come out to be how much? Simply 0.3 liters, right? It will be 0.3 liters. That is going to be your answer, okay? So that is option number C. It is your right answer. Correct? So no doubt till now. Okay, let's move ahead guys. Let's move ahead. So what were we doing? Just give me a moment. Yeah. So we were at next thing which we wanted to do is ideal gas equation. What is it? It is our ideal gas equation. So we discussed that any gas which strictly follows Boyle's law, Charles' law and Avogadro's law. Okay, any law which follows any gas which follows these laws, that is Boyle's law, Charles' law, and Avogadro's law. Boyle's law says that volume and pressure are inversely related. Charles' law says that volume and temperature are directly related. And Avogadro's law says that the volume and number of moles of a gas are directly related, right? So any gas which follows these laws is called as an ideal gas. उसको आप क्या बोलोगे? Simply that it is your ideal gas, okay? But we live in a real world. Our gas is ideal in nature? No. We live in a real world, so we have real gases, right? But in the first place, we will deal with the ideal gases, okay? And the equation you get after combining these three equations, that is Boyle's law, Charles' law, and Avogadro's law, what do you get? See here, you got this, that you can say volume can be written as it is directly proportional to nt by p, right? See, when you combine these two, so you from here you can say that volume is proportional to nt, and when you join it with the first one, so you can say that volume is proportional to nt by p, right? That's what you can say. So from here, what did we get? We get volume is directly proportional to nt by p. Now when you remove this proportionality sign, you will apply a constant. So from here, what do we get? V is equal to R times nt by p, right? nt by p. Now if you just simply rearrange it, if you send p to here, you will get that p into v, that is product of pressure and volume, comes out to be rnt. But usually just you can say conventionally we say like pv is equal to nrt. This is our intent, right? So pv is equal to nrt, we can say, right? Now this r is universal gas constant. What is this r? This r is a universal gas constant. All right. Okay, and this r can be again written as pv by nt. Okay, for 1 mole of gas, you can say it is pv over t, right? And we know that the product of pressure and volume, pv is a unit of work as well, so r can be defined as work per unit temperature, right? You can also say it in this manner, that your universal gas constant, what is the significance? It defines your work done per unit temperature for 1 mole of gas. For 1 mole of gas. That's what you can say, right? I believe there is no doubt till now, okay? So at STP, the value of R is 8.314 kilo per mole. It should be joule per mole, kilojoule per mole, okay, per Kelvin. So this is your Kelvin per mole, right? 8.314. Now if you combine the combined law can be written as P1 V1 by T1 is equal to P2 V2 by T2, because we know that this value will be again a constant, that is the number of moles into the value of R, right? So again the value will come out to be a I believe, guys, there is some problem in streaming, right? Let's check again. I'm trying. it's working or it's not working. It's on, right? Is it working now? Yeah, I believe. Okay, now everything is okay. I don't know why like the Wi-Fi was turned off. Like how Wi-Fi was turned off. Okay, cool. Is it okay now? All right. Okay, so we are done yet. We are done now. Okay, let's begin. Let's get started again. So what were we doing? It was, we said that PV is equal to nRT, right? This is our ideal gas equation. Okay, so we know that number of moles can be written as given mass by molar mass of the gas. So let's write it as PV is equal to, let's write N as your given mass, say capital W, and molar mass of the gas, say capital M, okay, by RT. Okay. Now if I tell you, like you already know, how do you define density? Let's write it here. You know that density is your mass per unit volume, like the mass you have over its volume, right? So let's write it as W, the mass you have, and volume. This is how you define density, correct? So from here, if I tell you that let's send this molar mass here and let's send this volume here. So you can say that P into this molar mass M will be equal to weight by volume RT. Okay. So what will you get? You will get, let's define density of the gaseous substance as D, we can say. Okay. And molar mass is capital M. So you can say that PM is equal to DRT. Okay. Or from here you can also say that the density of the gas D comes out to be PM by RT, right? It is equal to PM by RT. Okay, this is your result. I believe no doubt in this. There is no doubt in this result. Okay. So this is the relationship between density and molar mass of the gas. Okay guys, let me know if there is any doubt. Okay, let's move ahead. Next thing that we have for you is Dalton's law of partial pressure. So what does Dalton's law of partial pressure says? That first of all, it is applicable for a mixture of non-reactive gases. Please note that this is for a gaseous mixture of non-reactive gases. Please note this. Okay, so you will only define Dalton's law of partial pressure for your when the gases are mixed which are non-reactive in nature. So let's see what does this law says. So it states that total pressure exerted by a mixture of non-reactive gases is equal to the sum of partial pressures of the individual gas. So what do we mean? Say in a, like when there is a mixture, let's say that the P total, that's the total pressure of the non-reactive gases, will be equal to the partial pressure of the individual gas, like the pressure which individual gas exerted. So we'll just simply add them, P1 plus P2 plus P3 plus up to Pn, like the number of gases you have. Okay, if you have n gases. Okay, so in a mixture of gases, the pressure exerted by an individual gas is called its partial pressure. Mathematically, you can say that P total is equal to P1 plus P2 plus 3, P3 plus P4 plus up to Pn, like the number of gases you have. Okay. Now, pressure of dry gas can be calculated by subtracting vapor pressure of water from the total pressure of the moist gas which contains vapor too. Okay, so here is your equation for this. You must have done this in your previous in your chapter number 1, right? You have already done this. That is your what do you mean by vapor pressure and stuff. This you have already done, right? I believe so. Now let's move ahead. The next thing which we need to deal with is partial pressures. That was the you can say the pressure of the individual gas, right? So what is partial pressure of the gas in terms of mole fraction? Okay, that's what we are going to see right now. Okay, so let's see what is the relationship. Just give me a moment, guys. Let me adjust my phone and my system. Yeah, coming. Yeah, till then, let me know if you have any doubt in like what we have covered till now. Okay, just simply let me know if you have any doubt in whatever we have covered till now. Okay, so we have done all the, you can say, gases, all the gas laws we have covered. And what else have we done? Your like how your ideal gas is ideal gas equation is like how is it formed, that we have already done. Okay, so now let's see how partial pressure is related in terms of mole fraction. Okay, so what do we know? We also saw like Dalton's law of partial pressure. This we have already done, right? And what else do we know? So we covered that your PV is equal to nRT, right? If you see the ideal gas equation, you know already that PV is equal to nRT. This is simply your ideal gas equation. This is your ideal gas equation. So from here you can write the pressure of the gas as nRT by V, right? You can write it as, pressure can also be written as nRT by V. No doubt till now, right? Now we know according to Dalton's law of partial pressure. What can you say? According to Dalton's law of partial pressure. Dalton's law of partial pressure. What do you know? You already know that P total can be written as P1 plus P2 plus P3 plus up to so on, up to Pn. Okay, that's how you can write it. So we can also write it as, if I tell you that P1 can also be written as N1 RT by V. N1 RT by V, because rest of the things, R is already a constant, T temperature and volume, it's the same for all the gases. So we can write P1 as N1 RT by V. Similarly, we can write P2 by N2 RT by V, right? We can write it as N2 RT by V. Now, if you compare these two, so in the first place you will get that P1 by P2 can be written as P1 by P2 is equal to N1 by N2. It will come out. It will be equal to N1 by N2. Simply if you take the ratio of these two, that's what you will get, right? So remember this. Okay, according to Dalton's law of partial pressure, it is also valid that P1 by P2 is equal to N1 by N2. ठीक है ना? Remember this. Now let's change the slide. So what can you say if I tell you that P total, as we discussed, according to the your Dalton's law of partial pressure. So P total can be written as N1 RT by V plus N2 RT by V plus N3 RT by V, N3 RT by V, plus up to so on, right? Like the number of gases you have, take their moles, RT by V, right? That's how you can write it. So you can further say that P total, let's take RT by V common of them. Okay? So what will be left? You will be left with N1 plus N2 plus N3, right? And what did we take common? RT by V, we took it as common, right? Let me know, bacha party, if there is any doubt in this. Till now, if there is any doubt, any confusion, then just simply let me know. Okay? Pragya, Kavita, all the bachas, let me know. Okay? So now, if I tell you that if I want to write partial pressure in terms of mole fraction, right? That's what I want to write. Partial pressure in terms of mole fraction. In terms of mole fraction, right? That's what I want to know. So if I tell you to divide P1, if I tell you to divide P1 by P total, the partial pressure of one gas divided by P total, so what will you get? You will simply get N1 RT by V. Aniket Prakash. Yeah, beta. Aniket Prakash. The thing is, a lot of students don't even know that this category has been launched for ICSE and ISC boards. So that is why like very less students are coming these days. Okay. So I would tell you, propagate it, promote it within your friends. Once this once everyone gets aware about this, that this new category has been launched, so students will come. All right. Okay. So if I tell you, it will be N1 RT by V, right? And what is P total? We just discussed, right? We just sorted out what is the value of P total. So you can say it will be how much? N1 plus N2 plus N3 plus up to so on over RT by V, right? So this thing will be cancelled out. Your RT by V and RT by V will cancel out, right? So from here you can say that your P1 by P total comes out to be N1 over N1 plus N2 plus N3 plus up to so on. Okay, depends on how many how many gases you have. Okay, so that's how it came. So again you can say that this P1 by P total will be equal to how much? This comes out to be your N1, that is your number of moles of gas 1 over total number of moles, if I say it as N. Okay, so you can say that this value comes out to be equal to the mole fraction of the gas 1. So you can see that P1 by P total is equal to the mole fraction of gas 1. So from here you can say that the partial pressure of gas 1 is equal to the total pressure times its mole fraction. So that is how like this thing comes out, okay, that your P1 is equal to PT times X1. I believe there is no doubt till now, okay. Just simply let me know if there is any doubt. Aniket, Kavita, Pragya, tell me bacha party if you have any doubt in this, okay. Next, let's quickly discuss Graham's law of diffusion and effusion, okay. Next we need to do is Graham's law for diffusion and effusion. So like let's see in the first place what do we mean by diffusion. Like when you mix two gases, like say in jar A I have some other gas, in jar B I have some other gas. If you just open the lids of the gas, then what will happen? Those gases will simply mix with each other. So we say that this is diffusion, okay. So diffusion is a phenomenon where there is a movement of one material move from the area of high concentration to the area of low concentration. Yani ki the particles, like where the less number of particles are present, the particles will move to that side. This means that particles or molecules spread through medium. For example, if you spray at the end of the room, you would be able to smell at the other end. Why? Because the particles are going from higher concentration to the lower concentration. This is because of diffusion, okay. Now simply our Graham's law states that the rate of either diffusion or effusion is inversely proportional to the square root of the molecular weight of the gas. So what does it mean? Like the gases which are lighter in weight, they will get easily diffused, and the gases which are heavier, they will they will effuse or diffuse like they'll take time, right? So we know that effusion is a process in which air escapes or leaks through a hole whose diameter is considerably small, okay. So we know that rate is inversely proportional to the, what did we say? That it is inversely proportional to the square root of the molecular weight, okay. So that is what your simply Graham's law states, okay. So you can just say that R1 by R2 will be equal to under root of M2 by M1. This is your Graham's law of diffusion or effusion, okay. You can see here, right? Graham's law, which is known as Graham's law of effusion, was formulated by Thomas Graham in the year 1848, and you can see that M1 is the molar mass of gas 1, M2 is the molar mass of gas 2. So from here, rate 1 by rate 2 is equal to under root of M2 by M1, okay. That's what we have covered in today's class. All right, now let's move ahead. What else we have for you? We have kinetic theory of gases assumptions. You can see these are simply the assumptions. We need to simply study them, read them, and we'll get it, okay. So kinetic theory of gases considers the atoms or molecules of a gas constantly moving point masses की तरह treat किया जाता है, okay. So yeah, particles. Gas is a collection of large number of atoms and molecules. Very first assumption, very easy, right? Okay, that gases have large number of atoms or molecules, okay. And according to kinetic theory of assumptions, kinetic theory of gases, they are treated as a point mass, very small particles like a point or dot on a paper with very small mass. Okay, and it is assumed that those particles have negligible volume, that they don't, they have a very negligible volume. So particles, because particles are generally far apart such that their interparticle distance is much larger than the particle size, and there is large free unoccupied space in the container. So that is why we say that they have almost negligible volume, or you can say almost zero volume. Nil force of attraction, it is said in the kinetic theory of gases, these are the assumption that there is no force like that is acting between the particles of the gases. So particles are independent, they do not have any interactions among them. Okay, next is particles in motion. The particles are always in constant motion because of lack of interactions and free space available. The particles randomly move in the all direction. Okay, yeah, and it is assumed that when, like, comparatively to the volume of the container, to the volume of the vessel, volume of the gas is again negligible. So because of motion, gas particles occupy the total volume of the container, whether it is small or big, and hence the volume of the container is to be treated as the volume of the gas, because all, like, the gas is available in that volume only. Okay, so these are the kinetic theory assumption, and these are the postulates. Okay, so this is your homework to study the postulates. Okay, what I will let you know now is the features that I have for you in Unacademy subscription. Okay, for Unacademy subscription features. Now, as you know already that like, again, there is an outbreak of COVID, and so that you can just learn live from the comfort of your home, and you will have access to the unlimited number of courses. You can study with the top educators of India, and only on plus, like the plus platform, we cover 100% of the syllabus. The things which are missed here, they will be covered only on the plus batch. Okay, in the plus courses, and the plus batch is like launched, the another batch will be launched on 17th of January, and the name of the batch is Mavericks. Okay, so there is like regular doubt solving, we have exhaustive coverage syllabus for you, mentorship and guidance for you, the study material is given to you in the PDF format. There are regular practice tests, live test, and batch courses. So we have everything for you. Okay, and as you can see here, that these are the subscription plans for ICSE boards, and I would tell you that to get the subscription for a longer period of time, so that it will cost you less. You can see here, for 6 months it cost you, the effective like monthly cost comes out to be 1500 a month. But if you take the same course for say 12 months or 18 months, it costs you like 700, 800, 900 per hour per month. Okay, and even like after such nominal amount, you will get an additional off if you use my code, that is Kirti S Live. The code is Kirti S Live, and if you use this code, you will get an additional 10% off. So get it now, plus subscription. And as you can see that these are the batches which are going on. Param batch for class 9, and something amazing for you is that if you subscribe for class 9, you will get class 10, class 11 and class 12 subscription for free. Okay, so this is like a very good deal for you guys, right? You can see that this is for class 9, the English batch, in which the delivery is in English. Okay, this is for class 10, that is Param batch, again delivery in Hindi, Shivam sir, Vibha ma'am, Bhavna ma'am, Lakshya sir, right? These are all here. Then Champions batch for class 10, Champions batch for class 11, in which Sanam sir is teaching maths, I am taking chemistry, and Saurabh Verma sir is taking biology. Again, you can see here, if you take ISC class 11 subscription, you will get class 12 subscription for free. Okay, and after like applying my code, that is Kirti S Live, you will get more discount. You will get an additional 10% discount. Okay, let's move ahead. Champions batch for class 12, same teachers. You can watch the special classes, free special classes, which are free for everybody. Okay, so that you can be, familiar with the platform. That is the main motive here. And you can watch special class. You guys are way too smart for this. You know how to download an app. You know how to like register for the app. Just enter your phone number. You will get an OTP. Get your email verified. Tap on the category in which you want to study. Say if it's ISC 12, then click on it, you'll find me there. And that's it. Download the Unacademy app right now, and you can watch my live class. Again, in order to unlock it, wherever the code is needed, this code will work. Okay, Kirti S Live, this code would work. So you can just simply apply this. And if you want to reach out to me, you can do that. My username is Kirti_Sharma 1223. This is my username for Unacademy Messenger and Telegram. You can reach out to me and let me know if you have any doubt. That is it for the day. Be safe, keep smiling, and bye-bye.